Hello everyone. Today we're going to see some of conditional probability that's really important for the study of statistical methods. So, what is conditional probability? Here we are interested of events, for example, what is the probability of event B happening rather than, given that A has already happened. So in this case we have the probability, this is a simple probability of B, we want B given that A has already happened. This is the symbol that is used for this kind of problems. So, let me write it the other way because it's usually of A happening rather given that B happened. And this is the way. So there is an equation given for this, and I want to give you, which is the probability of the intersection of AB intersection over the probability of B. Now, a visual way to see this is that we have our two events AB. Since we are only interested in this little part of here, that is the probability of that this little thing here of this give us that B has happened, A has happened, so this is the probability of both happening. We are interested in this, and we divide by this part because this is like proportionality variation, because if we don't divide by this, our condition that our probabilities, the sum of probabilities has to be less than 1, it doesn't add up. So this is the way it has to be graded, so it can have that thing in mind and be proportional to this part of it that is what is interesting for us. But, so for example, let's see. We have example. We have a line, two lines, line A and line A complement, and we have two events B and B. This is if an equipment made by these different lines is defectuoso. This is not working, and working. So we have the result that is 2, 6, 1, and 9. So this is the thing that the equipment that they made that are not working, and this is the one working. And not working and working for each one of the two lines that we are taking about in this part. Now, what is the probability? Like if we go and choose one random equipment from all these ones, what is the probability that of choosing one that is of line A and is not working? So in that case, we want the probability of getting the line A, given that is a defectuous one. So this is easy because we need the intersection of A and B, and this table gives us that part. The intersection is this part, and this have a probability of 2 over 18, because we have 18 different parts, 9 plus 1 plus 6 plus 6. We have 2 over 18 to choose something that is of line A and also is not working. And we divide it over the total probability of choosing something that is not working. That will be 1 plus 2. That will be 3 over 18, because we have also 18 different parts. And our probability will be 2 over 3. So, as you can see, the only part that we're interested in this is this column of here, because it's the part that intersects here. It's the intersection of here, and it's the total probability of B here. Okay, so let me erase this. There's no eraser. Okay, let me erase this. Now, the next part. There is a property that is given in this part. Let me write it again. P or PB. Okay. We can solve for this equation. What if we are interested really in the intersection? What if we already have this part, but not the intersection part? We can solve for this and get this new equation. which is really useful in many cases where we don't really have this intersection but have all the other things to get this part. So let's see another example. So imagine you have DVD players. And we have three manufacturing companies, 1, 2, and 3. And we have the probability of going to a DVD store and choosing from one is of 50%. Of 2 is 20%. And of 3 and of 30%, and of 3 is 20%. And also, what is the probability that it's not working the DVD because they have some malfunction, something like that, not working? For 1 is 25%, for 2 is 20%, and for 3 is 10%. So we have our probabilities now. PA, let's call this event A1, A2, A3, and this call it B. Now the probability of A1 we already have it. Is this part, the probability of A2 and the probability of A3. Now, the probability of, we have here the conditional probability. This part gives us the conditional probability of each part of this. For example, the probability condition that we chose A1, given that it's defective, is equal to 0.25. And we have the same for each one of these. So, what is the probability? So, if we are looking for the intersection, what is the probability that we have both, like the probability of A and that is not working, of choosing this part? Because this is the conditional part of choosing one, given that this has already happened. But if we want the intersection that we have both at the same time, it will be easy because it will be the probability of A1 given B, the probability of, no, this is a mistake. Sorry. This is the probability that we get an effectus 1 given that this is from lane 1. I put it in the ground side, sorry. But yeah, probability that it is not working given that it's in lane A1. So what is the probability of that we have something from A1 and also it's not working? So we will be using the conditional probability of here, given that A1 has happened, times the probability of A1. So this is a really simple thing to do if we have this equation solved here, because we can do this. So we will be 0.25 times 0.5. And this will give us the probability of the intersection between this, that you have A and you have B. So it's a lot easy. So let's erase this part and we will see another law. Now, so other law that is important, let me see my hand. Other thing that is important is the law of total probability. Law of total probability. What is this? Well, there is an equation that goes like this. The probability of B, of the event B happening, is equal to probability of the conditional probability that B happen, that of B, given that A1 has happened times A1, blah 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 blah, and a plus the probability of B happening, of B rather than A2 has happened times A2, blah blah blah, until probability of B that AK times AK. Probability of AK. Probability of A2. Probability of A1 here also. Well, this is as the other one, but this is a sum of all the events A1 that this happened, and it will give us the probability of B2. There is a visual way to do it. Well, so in an easier way also this part will be probability of B or A1 and to AI. Now, a visual way to see is, for example, we have our whole universe here, and this is our event B. Now imagine that we divide this between the possible form that can happen. This is A1, A2, A3, and A4. Now, What we're interested is in the intersection between this, and this, and this. And as we saw in the last parts, this part is fully equal to probability of B intersection with A1, and this will be the same. So this is giving you the intersection of all of these. Given that also an important consideration is that A1, A2, A all that are mutually exclusive. This will give us the probability of PV in a total way. Now, other important theorem that we need to see is the Bayes theorem. Bayes theorem, which is given by probability of A, J, B, given that this has happened, is equal to probability of A intersection B over probability of B, which is equal using like the total of probability and the other things that we already saw. Probability of B of AG and probability of AG over the total sum, because you have seen BB is the total sum of all of this. Probability of AE times probability of AE. So now we can get this equation, that is the Bayes theorem, that if we sum all the probabilities of B, we can get the probability of AG, and at that an event AG happening, given that B has happened. And this is a really useful way of checking this part and to calculate probability. So let's see an easy example, so you can like check how this is done. It's more blue. Okay. So this is a test. So imagine there is a disease that only one people in 1,000 have it. So 1 in 1,000. Now there is a test that to know if you have it or don't you have it. Now the test, give me the test. If you have the disease, and is positive the test, that means that you have 99% probability of having the disease, because the test is not always that accurate. Now, if you not have the disease and this gives positive, this is equal to 2%, because there is this is also have some kind of uncertainty. So if you don't have the disease and this is the positive, you have 2% chance of not having the disease, Now, so let's see of the 2% chance of this happening. Now, let's give it names to the events. A1 means disease. O sea, means you have. A2 means not disease. And B means the positive test. Okay, so the probability of having a disease is 1 over 1,000 now, because it's the part that only one people in 1,000 have it. Now the probability of A2 in that case is only 1 minus probability of A1. That it will be 0.999 and it will be 0.001. Okay. Now we want to get first the conditional probability. This part gives us the conditional probability that we are looking for. For example, the probability of B of having positive, given that you have the disease, is 99%, or 0.99 if we put it all in decimal. And in the other way around is A2 is equal to 0.02 because we have it in that part. Now, what if we want to get the total probability of B? Because we have the conditional probability, but what is the total probability of it giving positive? That only that event happening. We don't care about the other two. We want to know if it is positive. So we can first get the total low probability that we have here, the PV, and we have this part A1 times probability of A1 plus probability of B2 probability of A2. So using the total probability, we can calculate this part easily because we have all this data, and this will be let me see, equal to 0.047. Okay, so this is the total probability that given that you make the test and you don't know if you have or not have the disease, there is a 0.047 probability of getting of having a positive result. Now, what if I want the probability that A1 happened, o sea, I have no having the disease, given that you get positive? Now we can do it as we have seen because we have already the probability of PV inside our data, and what we missing is the probability of B given that A1 happens and the probability of A1, which is all a lot, is because we have already calculated all of that, and this gives us a total probability. Oh, well, I can see it because I write something small, but with this we can calculate this kind of stuff using the equation of Bayes' theorem and the total law of probability. So we can now, for example, here we have like the specificity and sensitivity of the test, and here we have the probability of really having the disease, given that it gives you positive, because this can give you a false positive. So how certain can I be that I'm really having the disease? This is a probability that gives you this. This is why this conditional probability Bayes theorem and all that is really useful. So thank you for seeing the video. See you soon.